Today we got problem 1589, maximum sum obtained of any permutation. So we have some requests, and if requests just want the subarray sum, right? And now let's say that we get sum of all requests for a permutation, and we want to find the permutation which has the maximum sum, and we do it modulo this, which makes sense since we can do like 10 to 5 times like the whole array has sum of 10 to 10, and we can do the 10 to 5 times, so 10 to 15. Okay, so what I'm thinking, right, because okay, if we like this 1 3 and 0 1, so this and this, so that means that this number has to be, will there be twice, so, and these guys once and this 0, so ideally we want to put largest number here, and then the second, third and fourth largest here, and the smallest here, of course. So we basically just count for each position this, with prefix sums we put +1 here and -1 to 4, and then prefix is zero times n+1 for DE, so begin end in requests, or they call it start and end, then prefix as prefix e minus equals 1, if I, then ref I minus 1, and then we got the prefix sum here. I mean, do we really care though? Not really, I think. If e is less than n-1, we can do that, right? And then okay, so let's say we'll have like in this is like indices, right? We can do this, and then we do indices sort key lambda x, and then we do like minus px, right? No, we want to do minus prefix of x. So what this does is sorts decreasing orders indices based on prefix sum at that index, and then we want to do like num sort key lambda x minus x, and then as, and then we want to do like ans plus int I times nums I percentage mod return ans, and we simply define mod here 10 to 9 plus 7. I think that should work. 21, how did we get that? Okay, I mean, let's print prefix, I guess. Maybe I should print it here. Okay. Okay, still don't work, so in the nums, let's see. So 1 0 2 3 4, that's fair. And then we want ref int I, like that, right? Yeah, that works. Let's see. Okay, and where am I? Here. You wanna tell me you can do this in linear time? That's crazy. You should not be able to do that. That is ridiculous, man. Okay. This guy straight up just... That's crazy. But okay, I'm doing what he's doing. I guess... So let this be like, I don't know, prefix sums. Okay, so if we could know for each position how many times it be counted in total, we could then simply assign the highest numbers to the most frequent positions in the requests. Get the of numbers approach. We use beep line approach. Instead of adding +1 to the whole interval, we add +1 to start and -1 to end +1. After processing all requests, we calculate the prefix sum for all positions in ON. Which gives us the frequencies where n is the size of... that's a good question. I mean, n plus n log n. N plus Oh, I'm still recording. I just have insane itch. That's crazy, bro. Anyways, this is due to the fact that now, since we first go over all requests in OM, updating the prefix sums. Sort the numbers and since we store the prefix sum, okay, bye.